Okay, another example. This one was a little bit harder to figure out here, so I'll show you the process that I went through. So we're trying to solve for these two linear equations. We're finding 2 points and graphing the points and making the two lines and seeing where they cross over. So here the first one, x plus 3y equals -9. So I make my x and y chart, x and y. So I always like starting with x is 0, plus 3y equals -9. So yeah, that just leaves 3y equals -9. So 3 times something equals -9. So if I divide by 3, y equals -9 divided by 3 is -3. 3 times -3 is -9. So if x is 0, y is -3. All right, well, let's see. What else can I put in? Let's say if I make y 0, what will that do? Let's try that. If I go x plus 3 times 0 equals -9, well, x equals 3 times 0 is 0, x equals -9, that becomes 0. So, that's easy, so -9. But the problem is my graph here only goes up to -5. So I could try to extend it over 4 more lines and see what I could get, and it only goes to -5, -5. Or I could try to find another number that's in the range here. So what I did, I'm like, all right, well, -9, that's huge. What if I do x is 1? So I did that, and this is what I got. I got x is 1 plus 3y equals -9. So I got to isolate the 1, or the y, so I got to get rid of the 1 here. So I end up with 3y equals -10. And divide by 3, well, y equals 10 over 3, -10 over 3. That's kind of hard to graph, 10 over 3. But I notice I'm going to have to divide this by 12, or by 3. So if I make this a 3, that'll give me a -12. So that's when I went, okay, well, let's say I'm going to skip that one. If I make this a 3, so I went back, I'm going to erase this so I don't have to go too far down. So I did a little analyzing, and I saw if I make this a 3, well, this will make this a divisor of 3, the y, 3y. So here if I go -3, -3, so 3 minus 3 is 0, so that leaves a 3y, and -9 and -3 ends up being -12. Well, 12 can be divided by 3. So therefore, divide by 3, divide by 3. So y equals 12 divided by 3 is 4, but that's a negative, so it's a -4. Okay, so that's more plausible. I got these two here that will work for that one. And then if I extend it, of course, the 0, -9, 0 will be crossed. So I can go ahead and graph that one. So x is 0, y is -3. So x is 0, y is -3. So 1, 2, 3 down. Okay. And then if x is 3, y is -4. So if x is 3, so positive 1, 2, 3, then the y is going to be -4. So 1, 2, 3, 4. Okay, so there's my line. So we'll see if I can line it up, and you can actually see the slope too of this one. That's a terrible line. Okay, you can see the slope is 1 up, then 1, 2, 3 to the left. 1 up, 1, 2, 3 to, not too bad. Okay, So you can see there's my line. Then the next one, 5x plus 3y equals 3. So I got 5x plus 3y, move it up, Mr. Dan, equals 3. Okay, so let's try this one, my x and y axis, x and y. So I'm going to try 0 for x and see what happens. So 5 times 0 plus 3y equals 3. So 5 times 0 is 0, and that gives me 3y equals 3. Well, 3 times 1 is 3. I can see that one. Or if you divide by 3, so y equals 3 divided by 3 is 1. Okay, so now the challenge is to find another one. What if I make this 0? Let's try it. Let's go 5 times 5x plus 3 times 0 equals 3. So that'll leave 5x, 3 times 0 is 0. And then 5 times, ooh, that leaves me a fraction. If I divide by 5, divide by 5, x equals 3/5. So this one I got to divide by 5. So here I have to think about it. And so if this one I got to divide by 3. So what can I do to make this work? Yeah, if I go 15, if I go 5 times 3 is 15. And that'll give me, yeah, I think 3. I mean, you can do like 1, 2, but if you analyze it a little bit, I'm seeing that if I go 5 times 3 is 15, I go 15 minus 3 minus 15, that gives me a negative 12, and negative 12 is divided by 3. So I'm going to try that one. This gives me 3/5. That's kind of, ugh. So, oh, you couldn't see it either. Sorry about that. Gotta keep looking at the camera here. So let me try. So yeah, I did a little. Let's try. And you could go 1, 2 down this side. So the 0 over here didn't work. So I went. I could go 5. Well, let me show you real quick. 5 1 times 3 y equals 0. If I did 1 here, well, that's not going to work because that'll be 5. I'm sorry, I don't know why I put a 0 there. I'm trying to go too fast. For time, 3y equals 3. So you can see here, if I subtract 5, so that gives me 3y equals negative 2. So yeah, divide, and that gives me another fraction. So I don't like 1, but I saw, like I said, 3. If I go 5 times 3, I could do 2, then I could finally do 3. Usually, eventually, not too many, sometimes 2 or 3 tries, you'll get to one that actually will divide or work. So I'm just going to jump up to 3. 5 times 3, if this was 3 in here, I don't like that one, plus 3y equals 3. So 5 times 3 is 15, plus 3y equals 3. So now I can isolate the y, so negative 15, negative 15. So that's 3y equals 3 minus 15 is going to be negative 12. I like that because 3 can divide into 12. So that'll be y equals negative 4. So negative 4. So this one and this one I like. And that's why we show other methods. I mean, this one, when you get to some that are more difficult, it takes some work to find the two numbers that work. Okay? So now I can take those two and graph them. So if x is 0, y is 1. So if x is 0 and y is 1, And then if x is 3 and y is negative 4, so x is 3, 1, 2, 3, and y is negative 4, 1, 2, 3, 4. There it is already. I don't even have to, here's the one where they cross. Okay, so here's where they cross. So that would be the answer to this one. The system would be where they cross over. The x would be 1, 2, 3. And the y would be negative 1, negative 2, negative 3, negative 4. Okay. I hope this works. I feel like I did some babbling on this one. But it just takes some work to work some of them through. I hope it's helpful. The next video I'll show the answers and a couple more ideas.